Hello. Hi. This is an example of using PROC GLIMMIX for fitting a logistic regression with a random effect. So here's the data set. It's a data set from a multi-center trial. So you can see the four variables are center, treatment group, and number of patients assigned to the group, and the side effect is the number of side effects in the group. So this is a data set from which we can analyze the number of side effects in the multi-center trial. You can see here for the center you have 1, 1, 2, 2, 3, 3, 4, 4, etc. So you do have the same patient from the same center. So you may have a center effect, clustering effect. We want to take into account when we do modeling. So first, let me just read in the data set here. For the sampling, the 15 centers were randomly selected. Therefore, there are random variation across centers. We use a random intercept as the random effect to model the center effect. When you consider modeling, you want to consider sampling. Okay, so how were the sample selected? So here we had a population of centers, and we randomly draw 15 centers from that. So that is, we want to generalize our analysis results using the current sample to that population of different centers. So we can expect there are random variation across centers. So we need to take into account of that. The model is really the usual logistic regression model plus a random effect. Okay, so you can see the Pij is the patient that had a side effect, the probability of a patient J at center I who had a side effect. And it's a linear function of the treatment assignment group underscore J, so the J's group. Okay. Then you have the U underscore I. The I is for the center. So it is a random effects to model the random variation across the center. Again, this is not a continuous and normally distributed outcome, so it's dichotomous, side effect or no side effect. But there's a clustering in the dichotomous dependent variable. So that's why we need to use random effects to take into account of the center variation, the clustering within center. And PROC GLIMMIX is a generalization of PROC mix. And you can view this as a generalization from linear mixed model to a nonlinear mixed model, or you can view this as a generalization from generalized linear model and you add a random effect. Okay, and so the syntax for PROC GLIMMIX to fit a logistic regression with random effects is pretty simple. Okay, after a certain time period for development, now PROC GLIMMIX become pretty easy to use. At the very beginning, PROC GLIMMIX was a SAS micro, and there was like convergence problems and all kinds of issues. But now we have a tested PROC GLIMMIX here. Okay, so we can call PROC GLIMMIX data equal to multi-center, and it has a class statement for dummy variable coding, and the model statement is very similar to the PROC GEMMOD or PROC logistic or PROC linear mix. Okay, PROC mix. So model, you have here, you have side effect over n. So this is the relative frequency representation for modeling the dichotomous outcome. Okay, and equal to group, and solution, that's for the fixed effects estimation. And then to model the random effect, we use random intercept. Okay, so here, back to our model, we assume there's these random effects is actually, if we do a multi-level modeling, we can start from a logistic regression and then split the intercept into a fixed part, a fixed effect part, and a random effects part. So this we say a random intercept. So here we use a random statement and put intercept in there, and then subject to center. So that's the repeated measure indicator for SAS to loop through the repeated measures. So let's run it. So here's the typical outcome, very similar to the other type of SAS PROC outputs, regression output. So the estimation method is called the residual partial likelihood. Okay, and so you can see the number of events, number of observation read and used. So there's no missing data. Number of events 155 out of number of trials 503. And you have the dimension for different type of the parameters you're estimating. Tell you the optimization information, the technique, and there are a bunch of other techniques. Look into PROC GLIMMIX documentation, you can find there are different types of optimization techniques. And fixed effects using profile and starting from data. Iteration, it does take 15 steps for it to converge based using these criteria. So the difference between the two consecutive iterations is pretty small, and we claim convergence has achieved. Fit statistics, we get the -2 residual likely pseudo likelihood. So this is not a complete likelihood because we need to integrate out the random effects to form the likelihood. Okay, and then it has other the generalized chi-square and the divided by freedom. The degree of freedom is 1.1, so relatively close to 1. Okay, and then we have the covariance parameter estimate, and we have the that's the solution, the option in the model statement, give us a fixed effects test estimate, and then we have the type 3 estimate for the group effect. In this case, seems there is a treatment group, treatment effect after adjusting for the centering, the center clustering. Okay, and an additional show of the option LS means, it can be used to produce estimates of the group average logits and predictions on the scale of the original data. So this is just another demonstration for you to use the LS means. Okay, so it's very easy. You can just use LS means, then say group /CL and I link. Okay, the inverse link function there. So since you use the ODS select, so it's gonna just it will just showing you that part, the group list square means for group A and group B. So give you some estimate for the group averaged least means. And you can see two treatment group does have a different group mean. I think there are tests we can test if there's the group means are significantly different. Okay. Okay, so it's not very difficult to do a generalized linear mix model nowadays with the PROC GLIMMIX. Okay. Thank you.